Hello everyone. Today I am going to teach you the topic heterocyclic compounds of Unit 4, Paper 6. Okay. Now, what do you mean by heterocyclic compounds? Name itself indicates hetero. Hetero means a different atom. Okay. Different means other than carbon atom must be present in the ring structure. Okay. Cyclic means ring structure. So, hetero means different atom, okay, other than carbon. So, what is the definition? Cyclic compounds in which one or more of the ring atoms are of elements other than carbon are called heterocyclic compounds. Okay. In short, it is represented as HCC. Okay. Now, other than heteroatom means which atom? For example, oxygen, okay, other than carbon, that is oxygen, nitrogen, sulphur, phosphorus, etc. Okay. Now, what is the scope of heterocyclic compounds? They occur naturally, okay, as alkaloids, vitamins, pigments, which I already learned, alkaloids, vitamins, and then even pigments contain one heterocyclic compounds. Okay. Then they are important in biological processes in plant and animal cells. Then they are also synthetically prepared. Okay, why they are synthetically prepared? In what compounds they are present? Dyes, drugs, agrochemicals, and engineering materials. Okay, all these compounds contain what? Heterocyclic compounds in major proportion. All right. Now, what is the classification of heterocyclic compounds? Now, compounds with only one heteroatom. So, a number of ways of classifying. Compounds containing one ring structure, compounds containing more than one, okay, two ring structure, three ring structure, like that. So, these are the compounds in which you have one ring structure, okay. Compounds with only one heteroatom, which is the heteroatom in furane. This is the heterocyclic compound oxygen. Rest all corners you have carbon, correct, no? So, here carbon, this also carbon, this also carbon. What about this corner? Contains oxygen other than carbon. That means other than carbon is oxygen, which is heteroatom. Therefore, this is an example for what? Heterocyclic compound, okay. The next compound, instead of carbon you have sulphur, correct. Rest all corners you have carbon, here you have sulphur other than carbon, okay. Which is this compound? This is called thiophene, okay. What is the IUPAC name? Thiol. Thiol is IUPAC name. Thiophene is a common name. Okay. Now, this is another heterocyclic compound. Which is the heteroatom present over here? Nitrogen. Okay. Nitrogen. And here all carbon and hydrogen will be present. Here nitrogen and hydrogen. Okay. Hydrogen in all corners you have, but nitrogen is the heteroatom here. Okay. So, which is the name for this compound? Pyrrole. Pyrrole is the common name. Azole is the IUPAC name, okay. Then compounds having more than one heteroatom, okay, more than one heteroatom. These are the examples. Oxazole. Oxazole contains what? One oxygen atom. Oxazole contains, in addition to oxygen, you have another heteroatom, that is nitrogen atom, correct. Other corners you have carbon, this carbon as well as this carbon, okay. So, oxazole is the name of this compound. If you specify the positions 1, 3, exactly 1, 3 oxazole. Why? Because first place you have oxygen, third place you have nitrogen. So, 1, 3 oxazole, okay. Then thiazole. Thiazole contains sulphur and nitrogen. Thiophene is sulphur, thiazole contains sulphur and nitrogen. In addition to sulphur, you have nitrogen as heteroatom, okay. Then imidazole. Imidazole contains two heteroatoms, but they are same. It does not matter, okay, but there are two different. That means other than carbon, two nitrogen atoms are present. This compound is named as imidazole, okay. If you specify the positions 1, 3 diazole, first and third position you have nitrogen, therefore di, two same heteroatom, therefore diazole, okay. Then pyrazole is another example. Here also heteroatoms are nitrogen atoms, but they are same, okay. Pyrazole. So, this is position if you specify 1, 2. First and second place you have nitrogen atoms, two same heteroatom, therefore di, okay. 1, 2 diazole, alright. Now, 6-membered ring heterocyclic compound. Now, which are the examples for this? Compounds with only one heteroatom. Okay, single ring will be present, but 6-membered ring, one heteroatom. This is one pyridine. Okay. So pyridine contains nitrogen. Actually, here it is a mistake. Okay, here there is a mistake. Pyrimidine. Okay, pyrimidine contains 2 nitrogen atom. Pyridine contains 1 nitrogen atom. Okay, 1 nitrogen atom. So this should be nitrogen atom. If it is pyridine, here should be nitrogen atom, not oxygen atom. Okay, so pyridine, and then suppose you have got sulphur atom here, it is called pyrene. And if you have, okay, so one more sulphur atom, this also there is a mistake. Okay, so pyridine, you just can give an example. Okay, this pyridine, instead of oxygen you will have nitrogen. All right. Then compounds having more than one heteroatom. More than one heteroatom means this compound, 2 nitrogen atom will be present, 1,2-diazine. Okay, 1,2-diazine. This is pyrimidine. Pyridine means 1 nitrogen atom. Here this should have been nitrogen atom. Pyrimidine means 2 nitrogen atoms, 1,3 position. Okay. Pyrazine means 1,4 positions. All right. Next, condensed 5-membered and 6-membered ring. Okay, so these are examples for condensed 5-membered and 6-membered rings. One is 6-membered rings, other one is 5-membered ring. Okay, condensed 6-membered and 6-membered ring. Here both are 6-membered rings. You can see here quinoline. Okay, which are going to study in detail later. Quinoline, isoquinoline. What is the difference between quinoline and isoquinoline? Quinoline, you have nitrogen atom here. Isoquinoline, next place you have nitrogen. Okay, isoquinoline. All right. So these are the examples. Now nomenclature. How do you give trivial and IUPAC names? Okay. Commonly trivial names are used, and IUPAC naming are also done for monocyclic and few polycyclic heterocyclic compounds. Okay. So usually trivial names are more convenient and more widely used, but we can give IUPAC names also. Okay. Polycyclic compounds contain 2 or more fused rings which may be partly or completely heterocyclic. Okay. Trivial names are often used for polycyclic compounds. So most of the polycyclic compounds we usually name them as trivial names. Okay, we give trivial names. Now here is a table for nomenclature. Okay, suppose you have got oxygen as a heteroatom. Order of priority, if you have 1, okay, priority is 1, prefix is oxa. If it is 5-membered ring, ol. Suffix use must be ol. Okay. If you have sulphur, then second priority you should give. Then prefix use is dia. If it is a 6-membered ring, then ending must be or suffix must be in. Okay. Nitrogen, third priority. Okay. Prefix use is aza. If it is 7-membered ring, ipin. The suffix must be ipin. Okay. Phosphorus, fourth priority, prefix used is phosphor. Okay. Now what are the rules for nomenclature? The terminal A of the prefixes is generally removed when combining prefixes and suffixes. Okay. If you have more than one heteroatoms are involved, the prefixes are placed in the order of priority, that is oxa first, then thio and so on. Okay, oxygen to be given first preference, that's the meaning. Okay, oxa plus ol is oxol. If you have oxygen and 5-membered ring, oxa and then ol, suffix is ol, therefore name is oxol. Okay. Then the ring positions are designated by numerals or Greek letters. The simple heterocyclic compounds having one heteroatom are numbered in such a way that the heteroatom gets the number 1 or lowest number. Then the numbering is continued in anti-clockwise direction. Here one thing you should keep in mind, you should follow anti-clockwise direction, not the clockwise, anti-clockwise direction. Okay, that is important. When Greek letters are used, then the position next to heteroatom designated as alpha followed by beta and so on. Okay, next to heteroatom you should consider as alpha, next to that you should consider as beta, gamma, delta, like that. Okay. Now here are some examples. 3-methyl oxole, you can make out here 1, 2, 3, third position methyl group. Okay, heteroatom is oxygen, therefore 3-methyl oxole. Okay, 2-bromo, second position bromine, 2-bromoazine. Okay, 2-bromoazine because nitrogen is there. pyrazole, okay, 1,2-diazole, because second carbon atom replaced by nitrogen, first also replaced by nitrogen, therefore 1,2-diazole, okay. Pyrazole is the common name or trivial name. Then imidazole, okay, if you have 1,3 positions, it is called imidazole. What is the IUPAC name? 1,3-diazole, okay. Pyrimidine, pyrimidine you have 2 nitrogen atoms, okay, 2 nitrogen atoms in 1,3 position, so IUPAC name is 1,3-diazine, alright. Now, when 2 or more heteroatoms are present, numbering is done in such a way that oxygen takes precedence over sulphur and sulphur over nitrogen, like that, okay. Oxygen first preference to be given, next sulphur, next nitrogen to be given, okay. Now, examples, which are the examples? Oxazole, okay, or it is also called 1,3-oxazole, first and third. One is first preference to oxygen, therefore 1, next preference to nitrogen, therefore 1, 2, 3, okay, 1,3-oxazole. Similarly, thiazole. Thiazole, first preference to be sulphur. If you have sulphur and nitrogen, first preference to sulphur. Then go in the anti-clockwise direction. Okay, 1, 2, 3. Okay, you should, that is one of the IUPAC nomenclature. Okay, so you should follow anti-clockwise direction. So 1, 2, 3. Therefore 1, 3, thiazole. Okay. Then now let us see aromatic property of heterocyclic compounds, molecular orbital pictures. Okay. Now aromatic property of heterocyclic compounds. 4, 5 carbon atoms, okay, 3, 5 hydrogen atoms and 1, 2 hetero-atom are present. Okay. Then each carbon atom as well as carbon hydrogen atom carries 3 sp2 hybrid orbitals and 1 unhybridized p orbitals. Okay, usually they have 3 sp2 hybrid orbitals and then 1 unhybridized p orbital. Hydrogen carries s orbital, you know that hydrogen has only s orbital, therefore it carries only s orbital. Each sp2 hybrid orbitals of carbon atom and carbon hydrogen atom CH atom has as well as sp2 hybrid orbital of carbon atom and s orbital of hydrogen atom overlaps along the axis, okay, that is called end-to-end overlap to give sigma bond. If the overlapping taking place along the axis, sigma bond will be formed, okay. If it takes place not along the axis, sideways, then pi bond is formed, alright. Unhybridized p orbitals of carbon and heteroatoms overlap sidewise, okay, to give pi bond, okay. Unhybridized p orbitals overlap sideways to give what? Pi bond, okay. Then 3, 4 carbon-carbon bonds, 2, 4 CH and 1 CH-HC. In the case of 2, 3 heteroatoms are present and connected to each other. Sigma bonds are formed. Then in such case, sigma bonds are formed due to the end-to-end overlap of sp2 hybrid orbitals and s orbitals, okay. All the sigma bonds lie in one plane. If you have sigma 1, they all lie in one plane. They are sp2 sp2 or sp2s sigma bonds, okay. Now third sp2 hybridized orbital of each carbon atom as well as CH atom occupies lone pair of electrons, okay. These electrons play important role in aromaticity. Unhybridized p orbital of neighboring carbon atoms and CH atoms overlap sideways to above and below the plane. So always p orbital overlapping sideways taking place above the one half above the plane, other half below the plane, okay, that you know it, okay, the mechanism of overlapping, and the sigma bonds to give pi bond, okay. The obey Huckel's rule, okay, we are going to see later in the next slide what is Huckel rules, alright. Now what is Huckel's rule? The molecule should be cyclic, okay. So any compound to obey Huckel's rule, it should be cyclic molecule, planar and fully conjugated, okay. P orbitals every atom in the ring. So all atoms in the present in the ring should contain p orbitals. The molecule has 4n plus 2 pi electron. Then what is the other criteria? The molecule must consist of 4n plus 2 pi electrons, okay. N is equal to 0 or any positive integer. N starts from 0. 0 means it contains 2 pi electrons. So cyclic compound cannot exist, okay. So if n equal to 1, if n starts from 1, only you can have expect what? Cyclic compound, correct. So example benzene. So simplest compound is benzene, which has 6 pi electrons. You know that. Why 6 pi electrons? Because it has got 3 double bonds, 3 pi bonds, correct. 1 pi bond means 2 electrons. 2 into 3 is 6, correct. So 6 pi electrons. So benzene has got 6 pi electrons. How do you calculate? What is the Huckel rule? 4n plus 2 is equal to 6. You know that 6 pi electrons are present, therefore 4n plus 2 is equal to 6. 4n is equal to 6 minus 2, correct? 6 minus 2 means 4, or n is equal to 1. If you know the number of pi electrons, you can calculate the n value, okay, n value, which is unknown. For benzene, we find that n equal to 1, okay. So here n is equal to 1, not 0, it should be 1, okay. N is equal to 1, which is a positive integer, okay. So the rule is met. So it satisfied, benzene molecule satisfies which rule? Huckel's rule. Therefore it is aromatic, okay. That is the conclusion. Any compound, heterocyclic compound or any compound, if it obeys Huckel's rule, what is the Huckel rule? You should satisfy 4n plus 2. You should contain 4n plus 2 pi electrons. Then only it obeys Huckel rule. That means that it is a cyclic compound, okay. Now here are some examples. Huckel's rule for aromatic compound, number of pi electrons, okay, 4n plus 2. Benzene we already learnt, okay. Then pyrrole also, if you calculate the 4n plus pi electrons, okay, n equal to 1, it contains what? 4n plus 2 pi electron, that means it is cyclic. Even furane, n equal to 1, okay, you can calculate, okay. For each compound you can calculate, you will find that it has got pi electrons, that means n equal to 1, okay. Here in this compound, how do you say pi electrons are present? Here 2 electrons, one double bond means one pi bond, 2 electrons. Here 2 electrons, correct? One double bond is present, that means pi bond, one sigma bond, one pi bond. Always in double bond, one is sigma bond, one pi bond, okay? So 2 plus 2, 4. Another 2 are here, lone pair, correct? 2 plus 2 plus 2, lone pair. So total becomes 6, therefore 6 pi electron, that means n equal to 1, okay? Similarly here in furane, 2 double bonds are there. 2 double bonds means 2 pi bonds. 2 into 2 is 4. 4 plus 2 here lone pair. This lone pair comes. This doesn't come. Okay. So this will come. Okay. So it has got n equal to 1. Similarly here thiophene. Okay. N equal to 1. It has got 6 pi electron. Even cyclopropenyl ion. Cyclopropenyl ion. How many electrons are there here? 2 electrons, okay, 1 pi bond is present, so 2 electrons here, n equal to 0, 4n plus 2, n is 0, that means plus 2 means positive ion, okay, positive ion will be there, okay. So compound, neutral compound you cannot expect, if it has got positive ion, that means 1 pi bond, that means you can expect n equal to 0, okay. Pyridine contains 6 pi electrons, n equal to 1, okay. 6 pi electrons, you can see here 3 double bonds are there, so 3 into 2 is 6, okay. Similarly imidazole pi electrons is 6, 2 plus 2 4, 4 plus 2 this lone pair 6, okay. Oxazole also 6, how it is 6? 2 pi bonds, 2 into 2 4, 1 lone pair, okay, 6. Then pyrimidine anyhow 3 double bonds are there, 2 into 3 is 6, okay. Naphthalene alternate double and single bonds, how many are there pi electrons? 2 plus 2 4, 4 2 plus 6, 6 2 8, 8 plus 2 10, that means total 10 pi electron, that means n equal to 2. If you substitute in the 4n plus 2, okay, formula, you will find that 10 pi electrons, so that you will get n equal to 2, okay. Now I will stop at this stage, okay. Please go through all these slides. Any difficulty, please contact me, okay. Thank you.